Hey there, and welcome back. In this video, we're going to cover the control flow of if, elif, and else statements in Python 3. Before we get into the coding, I actually want to do a quick recap on one of the people who founded the digital logic that we're going to cover today. I kind of mentioned it in my last video, but I want to do a quick recap on who this person is. Now, I don't want to go too deep, but I just wanted to mention that this is George Boole, and George Boole lived in the mid 1800s. Okay, he was a self-taught mathematician, philosopher, and logician. I don't know if I'm pronouncing that right, but logician. He was self-taught, which kind of gives me a little bit of hope. If you can be such an influential figure, being self-taught is pretty cool. He wrote a book called The Laws of Thought. And in the book, he outlines something called Boolean Algebra. And Boolean Algebra is a branch of algebra which the values of the variables are the truth values, which is going to be true and false, 1 and 0. And this concept, this mathematical concept, is the underlying structure of all digital information. And it really has to do with what we're going to do today in Python, using only the values true and false to make our computer make more sophisticated decisions. So I just wanted to give a little shout out to my boy George, and before we get coding. So just a disclaimer before we really get into talking about if, elif, else statements, and Boolean logic, binary numbers. That's a completely different topic that I'm not going to be covering just because it is so deep and deserves a video of its own. And I'm really trying to keep us on track and focus just on the coding aspect. So if you're looking for what are binary numbers and how to count in binary and all of those things, that's definitely not what this video is about. We're not going to talk about binary as all the information in computers. We're simply going to talk about true and false. So to crack right into it, I've got my console right here, and we're just going to type in a couple commands. I'm going to set some variables. I'm going to say y equals true, and I'm going to say x equals false. So in Python, you type true and false with a capital T and a capital F. And if I print out y, you're going to see that y has the value of true and x has the value of false. Like I talked about in the data type video, we can actually print out the type of y and x. I can say type y, and you're going to see that it's going to say a bool, class bool. So that's the data type that y is. It is a Boolean value, and we call it a Boolean for George Boole, like I just covered a moment ago. So I can do the same thing for x. So you can see that both x and y are Boolean values, and their values are true and false. Now, we're going to get into this a little later on when we talk about expressions, but just real quick, I can say, is y equal to x? And it's going to be false because you've got true equals false, and those two values do not equal each other. We can think of Boolean values as either something with value or something without value. You'll see here in just a moment that anything that is of value and that is not 0 is going to actually be considered as true if you pass it as a Boolean. So there's this casting method, just like we do with the string or the int casting. You can go bool and then in parentheses, and then whatever you put in between the parentheses is going to be the value that's evaluated. So if I put in 4 and I hit enter, you're going to see true because 4 is of value. If I put 0, you're going to get false. So I'm just going to do a couple of these and you can kind of get an idea of what is considered true and what is considered false. So we'll say bool. So there's no value in here. So we're going to say false for that. But if I say bool, that's a value. So we've got a true. It really kind of goes on from there, right? If I say bool 0.0, you're going to get false. If I say bool 0.1, you're going to get true because there's some value. Negative numbers as well. If I say -4, that is still a value, even though it's below 0. So it's really just 0 value items that are going to be considered false. Everything else is going to be considered true. So a lot of the times you have a variable. So you have variable x equals, we'll just say hello. And we can basically just say if x, and then we can say print x has value. So you can see because x was not no value, if, we can think of this as if true, right? So when something's in the if statement, we can pretend like it has this Boolean caster. It's saying if this is true or false. If it's true, we're going to run. So now that we've kind of exposed the if statement, let's break into that in our actual code in our project up here and really explain how those work. For me, I think it's easiest to understand if statements if you kind of think about them in the real world without code. To start thinking about, you have some situation or you have some data, and based on that situation or data, you're going to make certain decisions. So on line 4, you can see I've written a statement. It says, today's my birthday, but I'm not sure where to hold the party, inside or outside. So that's our statement. So based on whether it's raining or not, we'll decide if we're going to have our party inside or outside. So we have a little mock-up of what an if-else statement would be. And we can just say, if the weather outside is sunny, then have your party outside. Else, if it is raining, have your party inside. So we can say that there's two values, right? There's either raining or not raining. And if the weather outside is sunny, meaning it's not raining, then that means we can go outside. But if it's not sunny and it is raining, then we'll go inside. So you can see that we evaluate the situation, or we evaluate the data, and whether the data is one value or the other, we make a decision based on that evaluation. And that's exactly what you're going to see in the code, the actual coding, the Python coding that we're going to do. But I like to think about it in terms of, on Tuesdays, I do my homework. Okay, is it Tuesday? No. Okay, don't do your homework. Is it Tuesday? Yes. Okay, do your homework then, right? So I like to, kind of think about that digital logic in the terms of how it would affect your life. If you're the program, what do you do based on the data that you evaluate? You have, sometimes you have two options, sometimes you have many options, and we're going to see that in the code exactly. And speaking of situations where you would have multiple decisions to make based on the data, maybe the data can be many different types. So I've got this silly example here, and it says, my mom always taught me how to tell if I need to take a shower. Of course, my mom didn't actually teach me this method. This is just some stupid thing I thought of. But so there's many different configurations or states that the data could be in, and we're going to check if the data is in those states, do something specifically. So we could say, if you smell like roses, then you don't need a shower. Else, if you can smell your arms reaching for a book, then you might need to use deodorant. Else, if you can smell your feet and your arms at the same time, then you might need to take a shower within a day. Else, you need to take a shower. So we have many different states that I guess the state of our stench could be, and based on what the state of that is, if it is true for that statement. So let's say that our data is what you smell like. If you smell like roses, that's either true or false, right? You either smell like roses or you don't smell like roses. And if you smell like roses, then you don't need to take a shower. But if you don't smell like roses, then this statement right here is no good. And we know that this is false, so we're not going to do whatever you're supposed to do down here. And what do? We go to the next logical statement and we say, okay, well, else meaning if this fails, else, if you can smell your arms reaching for a book, that's another possible state for our data to be in. And we're going to check true or false. Can we smell our arms when we reach for a book? Is that true or false? You either can or you can't. And if you can't, we continue on. We go to the next logical statement. We say, else, if you can smell your feet and your arms at the same time, then you might need to take a shower within a day. So let's say that that's the state of our stench data, right? We can smell our arms and our feet at the same time. So this statement is true. We're going to then think or do about whatever is recommended if this is the state of your data. That's the same thing in Python. We can check if data is in one configuration or state, and we can do something about it if it's true, or we can check if our data is in a different state. And we can go through this whole checklist, and depending on what the data is, depending on what the state of our data is, whether it's true or false for that statement, we'll do the code that corresponds with that example or that statement. Okay, so check this out. Now we can take those pseudocode examples where we are just kind of thinking about logic as it pertains to the real world. We can actually code those. That's exactly what code is meant for, right? Taking these real world situations and creating a program that does them for us. So let's take a look at it. We've got weather data. This is for the first example that we showed with the birthday party being inside or outside depending on what the weather is. So the weather variable is going to get user input, whether it's sunny or rainy. And then we're going to check. We're going to say if weather equals sunny, so that can either be true or false, right? The weather data can either be sunny or it can be something else, which would mean that it's false. It isn't sunny. And if it is sunny, we're going to run some code down here. Else, we're going to run some different code. So if this is false, if this statement is false, then we're going to do something else. So I'm going to run it real quick. I'm just going to go to run. You can see it says, please enter the current weather conditions, sunny or rainy. So I'm going to say it's rainy outside. And you see, weather is bad, have your party inside. So the program had weather stored, and it was storing the value of rainy. So it said rainy equals sunny, and that's false, right? Because rainy doesn't equal sunny. So it says, okay, well, we're not going to run this code inside of this if statement. Else, we're going to run this code down here, and that's exactly what we got, right? We got weather is bad, have your party inside. If I run it again, and I put sunny, it says weather is good, have your party outside. And that's because the variable weather stored the value sunny. And so it basically said if sunny equals sunny, print weather is good, have your party outside. So let's take a look at the second example of pseudocode that we did about how stinky are you, and depending on how stinky you are, you need to take a shower or not. The same thing as the weather one, we're actually going to get some user input, and we're going to store the data in a variable, and then evaluate that data compared to other possible states that the data could be, right? So we've got your stank level equals input, and then the prompt says how stinky are you, and then the user can put some of the possible degrees of stink. And the code right here is the same thing that we saw with the pseudocode. We have 4 statements, and each one evaluates the data to be in a certain state. And if the data is in a certain state, here, I'll even kind of spread this out like that so you can see. We've got 4 statements, right? And each one is going to evaluate the data to be a certain state. And if that data is that certain state, then the code beneath it will run. So we can see if stank level equals roses, then the program's going to print out, you do not need to take a shower. If the stank level is just arms, the program's going to print out, you might just need deodorant. And if the stank level is arms/feet, it's going to say you might need to take a shower within a day. And finally, if these 3 statements, these evaluation statements, if all of them turn out to be false, Then you have this final else statement. So if all else fails, run this code no matter what. There's no evaluation in the else statement. I'm going to talk about that in just a second. But you can see that we're going to check the value of stank level. Is it roses? True or false? False? Okay. Stank level. Is it arms? Does it equal arms? True or false? False? Okay, let's move on. Stank level. Does it equal arms/feet? False? Okay, then run this code. Okay, so let's go ahead and run that and let's see what happens. So it says, how stinky are you? And I'm going to say that I'm roses. So it says you do not need to take a shower. And that's because we evaluated if roses, right? Let's just imagine that this is actually just roses instead of a variable named stank level. We'll say if roses equals roses, then print this line. And that's exactly what we got. So the first statement to be true is going to execute. You can see, I could put this down here too. I'm kind of breaking off into the weeds here, but I'll say Elif roses down here, and you'll see that just this first one, I'm going to say, we're going to change this up so we can say, you are clean. Okay, so which one is going to run? If I input roses, if stank level equals roses, is this one going to run or is this one going to run? And I did just mention that the first statement to be evaluated as true will run. So hopefully you realize that this first one is going to run right here. So if let's run this code again. It says, how stinky are you? And I'll say roses again. And it says you do not need to take a shower. And this statement may be true, but this was the first statement. This right here was the first statement to be evaluated as true. So that's the one that executes. Now, if we run this again, bring this back up, and I'll say arms this time. So arms. And it says you might just need deodorant. So you can see that when stank level equals arms, the first statement to be evaluated as true is stank level equals arms. That's a true statement, and then it's going to print out you might just need deodorant. That's what we just got. So let's take a look at what would happen if I put in the wrong value. So let's say I smell like dirt. That's my stank level. It smells like dirt. It says you need a shower now. So if you can see, well, it wasn't roses. I didn't smell like arms. I didn't smell like arms and feet. And I didn't smell like roses again. Then we can get rid of this because that's illogical, essentially. None of these statements were true. So if all else fails, we're going to print you need a shower. If you're any other state, if your data is any other state besides roses, arms, or arm/feet, then it's going to trigger this else statement. I mean, I can put literally anything. I can put 5 in there, and it's going to say you need a shower. Hopefully your program doesn't bring the wrong kind of data to the if, elif, and else statement, but that's what I'm trying to show you is that 5 doesn't equal roses, and 5 doesn't equal arms, and 5 doesn't equal arms and feet. So it must be this one that executes, because none of these statements are reserved for specific states that your data could be in. And if your data is not in those states, then we're going to run this else statement. So we just had a few examples of our if statements or our conditional statements. And I want to just quickly run through a list of facts that I've outlined about if, elif, and else statements in Python that I want you to know before we move on. I am going to try to cover each one of these if I haven't already covered them. I have examples lined out for each of these statements, and like I said, we'll cover them. So just a quick recap. We'll say if keyword is always first. So in the if, elif, else statements, if is always first, and there can only be one. So as you noticed in all the examples, I had one if statement at the beginning that started with if and then had some conditional, and then the rest of the code below it. The elif stands for else if, and it goes after the first if block. So if is the keyword that starts the whole structure of your if, elif, else statements. And then after your first if, you have elif. There can be an unlimited number of elif statements. As you noticed in the first example, there was no elif statements. There was just an if and an else statement. And in the second example, we had two elif statements. So we had the first if, an elif, and then an else statement. The if and the elif require a conditional statement or expression that will evaluate to true and false, right? So every time you saw if or elif in our examples, there was an expression that followed that keyword, and that expression could be true or false. So if stank level equals roses, that can be true or false. If stank level equals arms, that can be true or false. And it's going to base whether to execute the code below it depending on what the state of that data is, whether that expression is true or false. The else block has no conditional statement attached. It is the last resort of sorts. As I always say, else, if all else fails, then run this code without checking anything. It has no conditional statement. It is just the keyword else and denotes that if all the other statements have been false about whatever you're checking, then run this code. So the else is always the last after all the if and the elif blocks. So if the if is first and the elif is between, the else is always last. I'm just thinking about this, but the else statement, there can only be one. There can't be two else statements, right? You can't have, if all else fails, do one of these two things. No, you can only have one kind of final solution, right? If all other conditions are false, run this code under the else statement. The first if and elif blocks to be found true will be executed. So you need to think about how the data will be received and ensure all possible checks are in the right order. We kind of showed this in the previous example with the stink level. If it was roses and we had two statements that say if stank level equal roses, the first one to be found gets executed. So we had an if stank level equals roses, and then 3 blocks down we had an elif stank equals roses. Well, the program goes through and it says, okay, well, this is the first one that I found to be true, so I'm going to completely ignore all the other blocks, all the other elif and else statements. The computer doesn't even recognize those statements after it finds one to be true. After the code in one of the blocks is executed, the program continues after the final elif or else statement. I said elif or else because else is optional. They're all optional, actually, but whatever is the final statement, once the program finds a block, a conditional block that is true, it's going to execute that code. And once all the code underneath it is executed, the program is going to return back to the bottom of the that whole entire conditional structure. So there can be an unlimited amount of code underneath any if, elif, else block. A lot of the time, programmers write simple if and elif statements, and let's say that if connection to a port is successful, run the program essentially. So you can think that all the code in your whole entire program can sit underneath an if statement, and the else statement could just be a simple output that says, oh, no connection found, killing program. Okay, so we'll of course we'll see these in the examples here in a moment. So, and then the final thing is the purpose of the if, elif, and else statement blocks are a concept called flow control. So the flow control, it gives the program more optional paths to take. As you've seen, depending on the data, the program kind of forks and goes in a different direction. You can kind of think of, obviously all the code is starting from the top and going down right now, but we can kind of think of it as the program finds a new path to take, and it decides to not take other paths. So think of it as a very easy way to build more useful programs that can uniquely handle data in different ways, right? As we've seen, depending on the data, the program is going to take one of these paths, and that makes your program more robust and more able to handle unique situations. So now that we've covered all of these little statements that I wrote out, let's go ahead and get back into actually coding the examples to explain most of these points that I just outlined. The first point in my list was the if keyword is always first, and there can only be one if block. So if we look at it, I've got this structured where the program actually starts off with an elif statement, says elif x equals 10. Then it says if x is greater than 20. You can see that we're already getting highlighted in red because the computer is kind of like, okay, well, I'm seeing this elif block, but I'm not sure what to do with it because the program needs an if statement first. So we can actually run this, and you see I've got an invalid syntax starting off with an elif statement. So to correct this, we would just need to take this if statement and place it above the elif, and you can see that we now get no errors, and I can run this and it can say x sucks because x was not greater than 20 and x was also not equal to 10. So the else statement executed. The next thing on the list was that there can be an unlimited number of elif statements, and you can see from my example that I have kind of an obnoxious setup here. I've got my first if statement, right, because everything starts off with the if keyword first. I've got my variable x here, x equals 20, and the program is going to check the value of x many different times. This is very, I guess, granular. It's going to check every single possible state, but I just want to show that you can have an unlimited number of elif statements. So we've got elif equals 15, elif x equals 16, elif x equals 17, 18, 19, all the way up to 20, and then we have our else statement that says x is greater than 20 if it passes all of these, right? So I'm just trying to show that there can be an unlimited number of elif statements, and if we run this, you're going to see which one's going to print out. Do you think you've got x equals 20? So if we look in here, is that statement true or false? Is that statement true or false? Is that statement true or false? You can kind of go down all the way through and say, okay, well, x equals 20, so which one of these statements is true? Hint, hint, it might be 20 equals 20, but I'm not entirely sure. I'm not too good at this. So if I hit run, you can see x equals 20. So the program went through all of these elif statements all the way down till it got to here. And this was the first statement that it read that was a true statement, right? Does elif x equals 20, and x did equal 20. So if I change this to, let's say 2, if I run it again, you're going to see x equals 2 because the elif statement that says if x equals 2, print x equals 2. Okay, so you can have unlimited number of elif. Remember, you can only have one if and one else. So let's make that else execute. Let's say 30. I'm going to say if, so it's going to go through and check all 20 times and see if x is greater or equal to that value. And none of those statements were true. So the else block printed out right here. Else, it says print x is greater than 20. Next up, we're going to show how the first if-elif block to be found true will be executed. So I have outlined basically 3 statements, and if you take a look, with the current value x equals 15, that is true. That makes each one of these conditions true, right? So if x equals 15, that's a true statement. If x is greater than 10, with x being 15, that's a true statement. If x is less than 20, that's also a true statement, right? Because 15 is less than 20, 15 is greater than 10, and 15 equals 15. So the first condition to be found true will execute first and ignore the rest of them. So if I run this, it says x is equal to 15. Now if I said, x is equal 11, which one is going to be true? this one is no longer true, right? Because 11 does not equal 15, but 11 is still greater than 10 and 11 is still less than 20. So if I run this, there you go. X is greater than 5. Oh, this should be 10. X is greater than 5. There we go. X is greater than 10, right? Because 11 is greater than 10. And we can go even further, and if I change this to 9, now we've set up where this is not a true statement. This is not a true statement because 9 is not greater than 10, but 9 is still less than 20. So if I run this, we can say X is less than 20. For my next trick, I will demonstrate that there can be an unlimited amount of code underneath the if, elif, or else blocks. Obviously, this is not an unlimited amount of code, but it is a decent number of statements underneath a single if statement. And x equals 5, and we're going to check if x is greater than 1, which is a true statement. So I'm going to run this code, and you can see that all of our hellos print out. Obviously, like I said, this is kind of a simple example, but you could imagine that you could have, loops and function calls and other if statements, which I think we'll look at here in a second. But you're going to have a bunch of different code underneath a single elif statement. Like I mentioned earlier, you could have a whole entire program that runs underneath a single if statement, right? So let's say that some kind of start off data needs to be the right state, and if it is, run the whole program. If it isn't, cancel the program and inform the user. One more quick example to demonstrate that any kind of code can go under an if or elif or else statement. I've got an if and an elif statement, and under them I have two function calls. You can see I have two functions up here. I've got the good life and the bad life. They are little function calls or little functions that I've created, just little one-line print statements that we'll see in a moment. And where we have a variable, like most of our examples, we have some data, and then we're again going to check the state of that data. The two possible values that we're looking for is either y for yes or n for no, and the prompt is, have you made good life choices? And then the user can choose whether they've made good life choices or bad, and get a specific call afterwards. And you can see that under the if, we've got a function call, which is going to then go into a function and run all the code. So it really does not matter what goes under the if statement, as long as it's indented, as you can see. So what if I have a print statement here, print here, I guess, whatever. That's not a part of this if statement. So if this was a true statement, that would run, and this would actually run subsequently, but it's not a part of the decision-making process. No matter what, it would run. You can actually see that this is not good because I'm interrupting an if elif. So when the computer sees this elif, it goes, hey, I'm supposed to be looking for an if statement, because it actually doesn't consider this if statement a part of this block right here. But I digress. I will delete that and we'll run this code real quick. I should pull this up. So have you made good life choices? I'm going to say, yes, I have made good life choices. And it says, welcome to the good life. You are now happy. And if we run it again and I put N for no, I have not made good life choices, it says, hello, this is Agent Beck with the IRS, because everybody knows that that's not good when you're getting phone calls from the IRS. So that is just to demonstrate that it doesn't matter what code you have under here. I could put, speaking of print statements, I can say finished the good life. Then we can take this. We'll say finish the bad life outside of it. So we can have whole sets of code after our or underneath our conditional statements, whether it's if, elif, or else. So if I run this again, you've got, have you made good life choices? Let's say yes, because I like the good choices. It says welcome to the good life. That was inside of this function, and then after that function returns, it will come here. Now I will make a video on functions. That's not what we're talking about this video. I'm just trying to demonstrate that there's unlimited amount of code that you can put underneath the if statement or the conditional statement that is executed. The very last thing that I want to cover is the conditional operators that you can use to evaluate two pieces of data. This whole entire program, I've either done equals, which is two equal sign. In programming, creating a variable, x equals 5. This is called the assignment operator. It's not called the equals operator. Now, if I do 5 equals 5, that's a Boolean operator. So it's going to evaluate the left operand with the right operand and give back a true or false value. So that's kind of the main one that I've been using for this video, just because it's very simple, checking if data is some certain state. Or I've also done the greater than. So if 5 is greater than 10, we're going to get false, right? Because 5 is not greater than 10, so that's a false statement. But if I did 5 greater than 4, that's true. So you have greater than, you've got less than. So I can say 4 is less than 5, and that's also true. We can do 10 is less than 3. I can also do strings as well and say if CA is greater than C, and that's going to be true because it takes the value of the C and the value of the A, and then it compares it to the value of just the C, and it says, yes, that's greater, because if I do, if CA is less than C, that should be false. Okay, so you can actually compare string sizes and values as well. Now, something like 4 is equal to 4, that's going to be false because those are two completely different data types. So you're not actually going to get an error. The computer's just going to say, well, no, that data is not equal to that data, right? The data on the left is not equal to the data on the right. You're not going to get some sort of error. So I could even do, let's see what happens if I do 4.0 equals 4. It's going to say true, but if I say 4.1 equals 4, that's going to be false, right? Because obviously those are two different values. Let's see what else have we got. And then, so we've done equals, right? We've got the equals, the greater than, the less than. So let's see what else we can do. We can do greater than or equal to. So we have, let's say 10 is greater than or equal to 5. That's going to be true because it's greater than or equal to 5. So that's true. And even if I do 10 is greater than or equal to 10, that's going to be true too, because 10 might not be greater than 10, but it is equal to 10. So we can do it the other way. I can say 10 is less than or equal to 5. That's going to be false, but I can say 5 is less than or equal to 10. And that's a true statement because 5 is less than. It's not equal to, but it is less than. So we've got the greater than or equal to and the less than or equal to. The last operator that we're going to look at is the not equal, which is a exclamation point and an equal sign. That's going to check to make sure that two values aren't the same. So 4 is not equal to 5. That's a true statement, but 5 is not equal to 5. That's an untrue statement or a false statement, right? So really all of these are just different ways that you can evaluate the data back and forth. This is really powerful. Once you start using these, you can really see that the possibilities are endless. I mean, if statements really make up so much of programming. So many pieces of control in your programs are controlled by if statements, right? Checking if the iteration in some loop is at a certain value, or here, let's do that right now. Let's go for I in range 10, and I'm gonna check if I is even. So I'll say if I divided by 2 has a remainder of 0, that's a statement. Okay, so if I divided by 2, this returns the remainder of a division operation. And so if it's an even number, it's going to be a 0 remainder. I'll say print we'll say I is even. And then else, right, which is going to be odd numbers, right? Because if a number is not even, it's odd. So else I'll print I is odd. So we should see our program is going to loop 10 times, and it's either going to print I is even or I is odd. Actually, let's change this to an F string. And when I run this, we're going to see 0 is even, 1 is odd, 2 is even, 3 is odd, all the way up to 9, right? It's 10 iterations. There will be a video on loops coming next. That will be the next video that I do, is working with loops and explaining how that works. But you can see that we have some data, this I variable, okay, this is called an iterator. This iterator variable is going to be the values 0 to 9, and we're going to use our if statement to check if the return of some math operation is a specific value, and then we print out accordingly, okay? So Boolean operators, I know that we just did the same thing as the equal sign. Again, we can do another thing. I can say if I is greater than 5, print I. So now this, if you can take a guess at what this is going to do, the program is only going to print I when I is greater than 5. So you get 6, 7, 8, and 9, because those are the only iterator values, the only values of I that are greater than 5. Now if I did if I is greater than or equal to 5, and I hit run, 5 is now going to be included, right? Because when I is equal to 5, it's also a true statement. So this video is getting pretty long, but I'm going to talk about one last thing. I know that the last two things I've said have been the last thing, but there's a lot of things to cover with if, elif, and else statements. And one of the things that we need to cover is a little bit more advanced. I would call it kind of step 2 in terms of building these conditional structures, is being able to combine multiple conditional statements together to get more granular outputs. So let's imagine that A and B are two different expressions that evaluate to true or false. That can be either a variable that is true or false, or it can be, a statement, a conditional statement, kind of like 4 is greater than 5, right? That's going to be false. Or it can be, the string Carter equals the string Carter, right? That's going to be true. Okay, so this table goes through a couple different examples of what would happen if you combined multiple conditional statements, and depending on their value and depending on the operator that you use to combine the conditional statements, what the output would be. Okay, so if we look here, we've got a variable A and B, and then there's 3 of these keywords. You've got and, or, and not. So if A was false and B was false, false and false is going to equal false. And false or false is also going to be false. But not false is going to be true. Okay, so that's what they do. They combine 2 conditional statements. So basically you can just think about it combining either true and false with true and false and seeing how they work together. So if A was false and B was true, the and connector would say false and true. So that's going to be false, because with the and operator, the and combinder, both values need to be true in order for the statement to output true. And with these same values, false and true, if we go to the or, you basically have false or true. So with the or combined operator, only at least one of the sides needs to be true. If they're both false, then you'll get false, as you saw with this one. So when A is false and B is false, if you do false or false, it's still false. But if one of the conditions is true, it only needs one to be true. Now, again, with the not operator, it's going to be the opposite of whatever the value is, whatever the output of that condition is. So it looks like this row is just taking A. So if we take false, not false is going to be true. So it basically flips the value. I know a lot of people get confused with this one, but it really just takes a little bit of practice. If you want to open up your terminal and just kind of input what it would, if you take your condition and then you put a not in front of it, it's going to flip whatever the value is supposed to be, or whatever it naturally is. It's going to take it to the opposite value. And let's see, we've got when A is true and B is false, the and would be true and false. So that's going to be false again. And if it's or, it'd be true or false, where there's one true statement and one false statement. So that's still true for the or statement. Now, again, A is true, so not true is false, and you're going to get the opposite of whatever the value is. And now let's look at what happens when both are true. So A is true and B is true. When you have true and true, now you have two values. Okay, that's the only time that the and operator is going to return a true for the combined conditional statements. You also have A or B, which is going to be true or true. And now not only do you have one, but do you have two true statements. So that creates a true output. And then again, as we've seen, A is true, so not true is going to be false. So super quickly, I want to show you, this is kind of exactly what the truth table that we were just looking at is doing. We have X equals true, Y equals false. So we have two conditional values. Again, this could be a statement, or it can just be the true and false value straight up. And you can see I have if X and Y. So that's what it looks like in Python code. That and looks like that. So if true and true, we're going to print out true. Else, we're going to print out false. So if you look at our two values, we've got X and Y. So it's if true and false. So we need both sides of this operator to be true. So when I run this, you're going to see an output of false. But if I change Y to true, now it's if true and true. And you can see we get the output of true. Now, if we change this to or, we get the same thing that we saw in the truth table. So now it's going to be true or false, right? So you have at least one side of the operand or the operator sides are true. So or only needs one side to be true in order to print out true. So again, we get a true statement. If I change X to false, then you're going to see that this statement no longer runs, because now it's if false or false, and it doesn't have at least one true, so we're going to get a false. And then finally we have the not. So I'm just going to go and put not X, and at this point we're only going to work with X, and it's going to take the value of X and flip it. So you can see this, if you hover over it, actually will give you a little detailed. It's kind of technical, but you can check it out if you want. So if not false, right? If not false, that's combining this and flipping whatever the value is from true or false. So you can see we output true even though X is false, because we're looking for if not false, which would be true. And similar, if I put true, because not true is false, so we get this false output. Okay, so that's everything that I have for this video. I know this was a super long video, but I really think that if statements are super important. They're used everywhere in your program, whether you're building a little function or you're building a large procedural program. If statements are really kind of the backbone to programming. Once you know how to work with data and you know how to make variables, then you need your program to actually be able to evaluate that data and be able to make responsive decisions based on the output of that data, right? Your program, if it just does one thing every single time, that's fine, right? If it just goes straight down, oh, I'm gonna pull this code. If your program just goes from top to bottom, that's fine. But a lot of the times, your program, you want it to do multiple things, as we've seen throughout this video, right? You want it to make better decisions based on what the data is. So I hope this video helped, and thanks for watching. If you like this video, please give it a like, and if you like the videos that I'm making in general, go ahead and subscribe. The next video that I'm going to make is about loops. So we did a for loop in this video already, but I want to go ahead and make a whole video on what a for loop is and what a while loop is. So there's two ways to kind of automate your code, and I think that that's kind of the next logical step in learning programming. So thanks for watching. We'll see you next time.